This is introduction class, introduction to the course and introduction to the signal. So here we are going to discuss about what is a signal, what is a signal, we are going to see, and this is the first point we are going to discuss. What is a signal, what are the examples of signals, and what is the definition. Then we will see signal classifications. We will see signal classifications. Then we will see system definition and examples. We will see notations of signals, notations of signals. What is a signal? So let us take some examples. In the day-to-day life, from morning since we go to the bed, we will see, or we will at least utter the sound signals at least 10 to 20 times. We will say signals in this week in my mobile, there is no signal in the mobile. Can you come out of your room? I cannot hear you, there is no signal, it seems at your place. Such kind of things we can see. And we will see traffic signal, some road signs, some many in the day-to-day life we will see some kind of examples of signals. So if you look at all these examples, a traffic light signal, a road sign, or some indication like the one person just giving a gestures, hey get up, hey what is your name, just get up from there. Without even telling anything, he will say simply, then that person will get information that he has to get up from his place. And in olden days if you see, people used to send information from one place to other place using the pigeons. They used to tie something to the legs of the pigeon and send it to the other place. And these telegraph systems, letters, telegraph systems, everything, emails, or everything, some kind of message or information which we are sending can be treated as all examples of signals. So just like take example of this traffic signal, what it is telling, we have to wait if the red light is there. It is conveying information that I have to wait there. A green light comes indicates I have to cross that zebra crossing. I am allowed to move there, move from that place. Road signs indicates that I have to go to either left side or right side. So such kind of examples, what they are telling us is signal is a physical quantity which is conveying some information, or signal is carrying some information. So as we have discussed about some general examples, now let us look at the examples in engineering terminology. Signal examples are of two types, electrical signals and non-electrical signals. Electrical signals are voltage, the telephone signal, radio signals, TV signals, etc. These are examples of electrical signals. And the voltage, even the whatever the current which we have, all these are examples of signals. And coming to the non-electrical category, we have sound signal and the pressure signal. The one which you are hearing, my voice itself is a signal, which is a sound signal, which is a non-electrical signal. So these are the examples of signals. Coming to the definition. So let me tell the definition. It is any physical quantity. I am drawing a graph here. This is x-axis and y-axis. Signal is any physical quantity that is varying with respect to, in this case it is varying with respect to time. On x-axis I will take time. A signal is any physical quantity that is varying with respect to one or more than one independent variable. So it could be like time, space, or anything. On the y-axis, I will take amplitude. So signal is any physical quantity that varies with time, space, or any other independent variable which carries some information. Other example of other definition of a system is it is a function of one or more independent variables that carries some information or that conveys some information. I told you already examples. What are the examples? All those things. Now coming to the classification, one more example. If you look at another signal, it is any physical quantity that is varying with respect to time. It is any physical quantity. It is any physical quantity that is varying with respect to time. Here, three signals which I have drawn are having different amplitudes, different, of course, same phase, but different amplitudes are there. So, just for the information sake, I am telling you that a signal is any physical quantity that varies with respect to time, space, or any other independent variable. But in our real life, we will use independent variable as time itself. We won't use space or anything else. So, whatever I drawn here is called as the graphical representation. This is called as graphical representation of a signal. Then whatever I am speaking, the statement of the signal, it is any physical quantity which is varying with respect to time, space, or any other independent variable, is the definition of a signal. And there is one more representation, that is, I will write this as the red one, which is in red is x of t. I will give a name to the signal x of t. X of t is equal to r of t. This is a ramp signal. So I wrote it in an expression. This is a mathematical equation. X of t is equal to r of t. This is called the mathematical representation of a signal. This is called the mathematical representation of a signal. Now let us see the other examples as well in this. X of t is equal to sin t, and the one more, which is x of t is equal to some square of t. Okay, so like this we can represent the signal in terms of mathematical expressions, mathematical representation, graphical representation, and the definition in a general statement. So that is about the signal. Now coming to the signal classifications. There are two types of classifications. Signals are classified as multi-channel They are also classified as one-dimensional or they are also called as multi-dimensional. Signals are of three types: multi-channel, one-dimensional, multi-dimensional. What type of signals are called as multi-channel signals is a signal which is generated from multiple sources. For example, take a EEG or ECG. They will connect multiple sensors to the patient body, or like if it is a heart, ECG, they will connect sensors here near the heart. If it is EEG, they will connect sensors near the head, brain. So there we are generating a signal from multiple sources. Such signals will fall under the category of multi-channel. Coming to one-dimensional signals, all signals which are having only one independent variable is called as one-dimensional signal. Example is x of t. Here there is only one independent variable. If you take the third category, multi-dimensional, it is called as, why it is called as multi-dimensional? Because a signal is having one or more independent variables, t1, t2. This is a two-dimensional signal. I can go with T1 comma, T2 comma, T3. This is a 3-dimensional. Like that we can get multi-dimensional signal. A signal which is having only one independent variable is called as one-dimensional. A signal which is having one or more independent variables is called as multi-dimensional signals. There is one more classification. These signals are of 3 types: continuous in time, discrete in time, and digital. We will call it as analog signals, continuous in times or analog signals, discrete signals, digital signal. So let us see what is a continuous in time signal or analog signal, what is a discrete signal, and what is a digital signal. Just take an example. If a signal which is defined for every x-axis value, for every time instance, it is defined. This is an example of a continuous in time signal. Time and amplitude. Second example for a continuous in time signal. A ramp signal. Time. This is R of t, we can write directly. It's an basic elementary signal with notation R of t. We have one more example, which is a unit step U of t. These are all the signal examples of continuous in time signals. This signal is defined for every instance of time. At origin we have a value. At 0.001 we have amplitude. At 0.1 we have amplitude. At 0.2 we have amplitude. At 1 we have amplitude. So on up to this last value. For every time instance we have a value. Here also same. Such a signals are called as continuous in time signals or analog signals, and a system which is processing these signals is called as analog system. Our analog communication will depend upon this type of signals. Coming to the discrete signals. Which signals are called as discrete signals is a signal which is defined at some points of time only. Like at origin we have a sample. Here we have another sample. Here we have another sample. This is x of t. This you observe both. It is defined for every value of time, but is defined for only certain values of times. It is not regular. It is defined at some intervals of time. But you observe here, these intervals are regular. The width between this and this, this and this and this and this, all are same. Of course, while drawing some extra space came here, but the width between these samples is unique. So a discrete signal is a signal which is defined for discrete values of time, which are actually regular intervals of time. It is, if it is 0, this is 1, then 2, 3, 4, like that. The difference between the samples is 1. So samples are defined at regular intervals of time. They are discrete, they are not continuous. So such a signal is called as discrete signal, and the notation will be, we will take it as x of n instead of x of t. The independent variable is represented as n here instead of t. So this type of signals are called as discrete signals. Similarly, we can draw for ramp and unit step also. Let me draw that. For ramp, same. So these are discrete signals. Now coming to the special category, digital signals. Today we are talking about digital India, digitization. Everywhere we will use this word digital media. So what is a digital signal? Digital signals are nothing but they are same like discrete signals, but the magnitude of a digital signal is quantized. The magnitude of a digital signal is quantized. It looks as it is. It is a special category of discrete signals. It is same like discrete signals, but the only difference is the magnitude of a digital signal is quantized. So if I have drawn a digital signal, a general digital signal, it may look like this. Something like this. Just an example of a digital signal. So these are the three categories. I said already, analog communication will depend upon these signals. Digital communication will use discrete signals whose magnitudes are quantized. And the advanced subject of this SMS is digital signal processing, where we will discuss more about discrete signals. Signals and systems will focus more on continuous in-time signals. All the problems, the majority problems which we are going to solve will be based on this category than this. So that is about the classifications of signals. We have seen two classifications. One is multi-channel, one-dimensional, multi-dimensional. Second one is continuous in-time, discrete and digital. There are so many other classifications. We can get signals as even, odd, energy and power, deterministic, random. Like that, so many other classifications are there. In the coming classes or in the coming videos, we can see such kind of different classifications whenever or wherever it is required. Now let us move to the next topic, that is, what is a system? If the audio signal which is coming from my mouth, if it is weak, if you cannot hear me, the audio which is coming, or the audio signal which is coming from my vocal cords through my mouth, if it is not audible to you, what could be the solution? I cannot shout more than this. You cannot sit without hearing just by seeing me. So what could be the solution is, I can use an amplifier. I can connect a mic. That amplifier will increase my sound, whatever I am speaking, it will take that as input and it will give you more sound which is audible to you in the speakers which are available in the classroom. So such a device, which is, just take a box representation, such a device which is taking a input signal, my audio signal which is given as an input to the device, it is doing some processing on that signal and giving you the output. This is the input which we are giving. We will use an addition x of t. Just now I told you what is x of t, a signal which is continuous in time notation. For the other one it is x of n for discrete. So x of t is a signal which is given, the sound wave which is given to the system is processing and we are getting the output. That output notation is y of t. So from this what we understood is, a system is a physical device. You cannot see the audio waves which are coming from my mouth, but the amplifier which is available or the mic which I am connecting is visible. It's a device. So system is any physical device that will take an input signal, process it and gives you an output signal. The other name of the input is called as excitation, and the other name of the output which you are getting is called as a response. And if I consider the transformation which I am going to apply on the signal or the processing, what kind of processing I am going to apply in the system, if I use a notation as h, the transformation, transfer function of the system as h, then the relationship between output and input will become y of t will be is equal to h of x of t. we are performing some kind of transformation on the signal. So signal is getting amplified and coming out. Say for example, if my voice is more louder, which you cannot tolerate in the class by sitting in front of in the first bench. So then in such case what you have to do, you cannot send me out because I am your teacher. You have to listen to me. You cannot put cotton in your ears. You cannot completely hear me. So what you can do is, we can use another device called attenuator, which will reduce the strength of the signal so that you can get an appropriate output. So just take an example of your microphone, earphones which you are connecting. If some sounds will be having more audio, you will be reducing the voice. If you want to hear more for some other songs which are not that audible, you will increase the volume. So that's kind of all devices are systems. They are taking an input signal, processing it and giving it the output. So that is about a system definition and examples. General examples I told you, like attenuator, amplifier, like that. Even the set-top box which we are using now for watching digital TVs. The high definition TVs which we are getting, all will come and fall under the category of these systems. Now let us switch to the other topic, that is notations. We will make it fast. Notations. It's very clear in the discussion only. You came to know that notations. X of t is a continuous in-time signal. Then x of n, it is discrete in-time signal. So as of now, these notations are enough. In the coming classes, we will see what is the transformation of this x of t. It will become x of omega, or x of f, x of s, x of z. The output notation is y of t. Other notation for output is y of n. This will become capital Y of omega, capital Y of f, such kind of notations which we will see in the coming classes. But as of now, you can remember these two. X of t is a continuous in-time signal, x of n is a discrete in-time signal, y of t is the output which we are obtaining for this, and y of n is output which we obtain for a input signal.